final value theorem. Limit t tends to infinity, y of t equal to y of infinity equal to limit z tends to 1, z minus 1, y of z, y of z. Consider z transform of y of n plus 1 t minus z transform of y of nt. This is equal to what? By definition, this is equal to sigma n equal to 0 to infinity y of n plus 1 t z power minus 1 plus minus sigma n equal to 0 to infinity y of nt z power minus n. This is by definition. The left hand side, we know that z transform of y of n plus 1 t is z y of z minus z y of 0 by definition. We know that z transform of y of nt equal to y of z. But y of n plus 1 t is z y of z multiplied by z minus z y of 0. For this, by definition, it is y of z equal to, this can be written as limit k tends to infinity sigma n equal to 0 to k y of n plus 1 t z power minus 1 minus sigma n equal to 0 to k y of nt z power minus n. This can be written as limit k tends to infinity y of n plus 1. So if you put n equal to 0, you will get the first term is y of 0 minus z power 0 minus y of 1 z power minus 1 plus etc. minus here the first term is when n equal to 0, y of 1 starts with y of 1 z power 0, n equal to 0 plus y of 2 n equal to 2 t y of 2t z power minus 1 plus y of 3t z power minus 2 plus etc. minus y of 0 z power 0 plus y of t z power minus 1 plus etc. This is for this. Here, take limit z tends to 1 on both sides. Before that, we'll write one more step. Limit k tends to infinity. Here, y of t minus y of, here, the coefficient is y of 0 you can combine these two, z power 0 term minus plus y of 2t, y of t, y of 2t minus y of t, z power minus 1 plus etc. plus y of k plus 1 t minus y of kt. Take limit z tends to 1 on both sides. Limit z tends to 1. Z, this can be written as one more step. Z minus 1 y of z minus z y of 0. If it, this is in the left hand side. So z minus 1 y of z minus z y of 0, that is left hand side, equal to right hand side. If you see y of 0, right hand side also we are taking limit z tends to 1, limit k tends to infinity. What you are getting is y of t minus y of 0 minus y of 2t minus y of 1t. Z power minus 1 plus y of 3t minus y of 2t z power minus 2 plus etc. plus y of k plus 1 t minus y of kt z power minus n, z power minus k. That's all. Here, as z tends to 1, these are all becomes 1. As z tends to 1, these terms becomes 1. That's why these are all getting cancelled. Y of t, these two getting cancelled. This and this getting cancelled. 2t getting cancelled. Except this term, all terms except this and this, all terms getting cancelled. Therefore, we can write limit k tends to infinity y of 0 plus y of k plus 1 t. All terms becomes 0, getting cancelled. The left hand side we are having limit z tends to 1. If you apply limit z tends to 1, z minus 1 y of z minus, if you put to z equal to 1, you will get y of 0 only. So here this is minus y of 0. These two getting cancelled. These two getting cancelled. Therefore, no k is there. That's why these two getting cancelled. Therefore, we got limit z tends to 1, z minus 1, y of z equal to limit k tends to infinity, y of kt. K plus 1 can be, as k becomes infinity, this plus 1 becomes immaterial. That's why y of kt we can write, or simply we can write y of infinity.